Question 8 asks which graph shows the graphical solution to the radical equation 0 equals 2 times the square root of x minus 5 minus 2. So we can think of this radical equation as a function, and if we do that, what we get is y equals 2 times the square root of x minus 5 minus 2. And if we look at this function, it's in the form of y equals a times the square root of b times x minus h plus k. And so this general expression, when we compare to the simplest function of this sort, y equals the square root of x, a stretches the simplest function vertically or compresses it vertically, b stretches or compresses horizontally, h moves the function to the left or right, and k moves the function up or down. So taking that into account with the function we have, we can figure out what this function looks like compared to y equals the square root of x. So first thing I'm going to do is draw y equals the square root of x down on this coordinate graph here. So when x is 0, y is 0, so we have a point at 0, 0 here, and when x is 1, y is also 1. So I'm going to say that this is 1, 1 here, graph that goes through here, and it generally looks something like that. It's not perfect. But so let's see what happens to this function when we do all these changes to it as in the function that we're interested in. So a equals 2 in our function. So that means that we've done a vertical stretch. H equals 5. And this means we've moved to the right by 5 units. And k is negative 2. And this means that we've moved down 2 units. Sorry, I'm not sure if I was completely clear with h. We know that it's positive 5 because this minus here is implicit in the general form of this type of function. So h is positive 5, we move to the right. If it was negative, we'd move to the left. K is negative 2, so we move down. If it was positive, we'd move up. All right, so let's see how this function's moved here. Start with our point at 0, 0. We've moved it over 5 units to the right. So 5 is about there. And we've also gone down 2 units. So this is negative 2 here. So this is where our origin is now. And our point at 1, 1, it's also moved over here. And it would be, if we extend this graph a little bit, sorry, that's pretty messy. It would be about here if a was 1, but since a is 2, we've done a vertical stretch, so it goes all the way up to the x-axis here, and it crosses, sorry, this is quite hard to see, at 6. So with that vertical stretch, this point at 1, 1 has moved up here. So our graph looks something like this. Okay, so now let's think about what this question is asking us. So since our equation is 0 equals 2 times the square root of x minus 5 minus 2, we want the solution to this. So we're interested in what x is when y is 0. So when y is 0, what is x? And looking at our function, we can figure this out. So when y is 0, x, we can see, is positive 6. So looking at our options here, If x has to be a positive 6, we know that b can't work, because that's a negative 6, and c can't work. Both a and d have a point at 6, 0. But from what we've drawn, we've shown this function going up, and that's because a is positive here. If a was negative, this would flip the function or do a reflection in the x-axis. So that would be what we're seeing in D. But since it's positive, we keep it going upwards, and so A is the right answer to question 8.